Hello everyone, this is Pablo and today I'm going to explain my project. It is called Best Starter 11 Team, Building the Dream Team with Big Data. So basically, imagine that you are the sporting director of a top European football club. Transfer window is open and the board is pushing for results, and you have one question in front of you: who are the best players available and where do they fit? Sometimes the reputation of some sporting directors have always driven these decisions, but what if data could do it better? And that's the goal of this project. So basically, using PySpark on Google Colab, I process a real-world dataset of over 2,800 players from the 5 major European leagues during the 2024-2025 season. Each player came loaded with dozens of statistical attributes, such as goals, as you can see here, uh, goals, assists, passes, tackles, saves, and much more. The challenge was not collecting data, it was turning that raw information into something more specific. So as you can see here, we have the total number of players, the positions of each player. So we have some players that play in 2 or 3 positions. So I only want one position per player. So I keep the first position and I count the total number of players by position. Then I filter out noise. So I wanted players with fewer than 500 minutes played because for example, 3 goals in 80 minutes of total play times tell you very little about a player's true level. Only those with meaningful exposure on the pitch were considered. Um, then next came one of the most important methodological choices. Instead of relying on cumulative totals, I decide to use a relevant metric using a normalized to per 90 minutes, as you can see here. This is the gold standard in modern football analytics, and it levels the playing field between a starter and a rotation player who might be equally dangerous when given the chance. From there, as you can see here, I convert the statistics to 90 minutes, as I mentioned before, and then I build 4 position specific performance model, each with its own weight scoring formula. So for the forwards, forwards are scored on goals, assists, and shots per 90 minutes, rewarding efficiency and attacking about all else. I create the offensive performance metric to evaluate the forwards. I also sort the forwards by performance, and it shows the top 3. We have here the top 3: Ousmane Dembele, Omar, and Alexander. Then we continue with the midfields. They are evaluated on key passes, progressive passes, assists, and defensive recoveries, capturing both creative and work rate dimension. So I create the metric here. I continue sorting the midfields scored, and finally it returns the best 3 players. We have Pedri, Joshua Kimmich, and Bruno Fernandes. And then we continue with the defenders. Defenders are ranked by tackles, interceptions, clearance, and blocks, quantifying how much they actually stop the opposition. Same process, I create the new metric, I sort the defense by defensive score, and finally it returns the best for defense. We have here Ardian, Patrick, Omar, and Murillo. And then finally we finish with the goalkeeper. This player is measured by save percentage, clean sheets, and goals allowed per 90 minutes. And same process, and we have the final result was these players, all of these. And then each model rank every eligible player at their position, and the top performance were selected to fill out the 4-3-3 formation, one of the most used system in modern football. As you can see here, the final 11 assembled entirely by the data, future name like Dembele, Marmoush, and Sorloth up front, Kimmich, Pedri, and Bruno Fernandes in midfield, and defensive line by Ismail, Mainka, Alderet, and Murillo, and Miles Levar in goal. And finally, the starting lineup was visualized on a football pitch built with Matplotlib. Each player plays in their position, colored by role. As you can see, defense on green, midfields on yellow, and strikers on red. Beyond the results themselves, this project is a proof of concept of something bigger, that big data tools can bring rigor and objectivity to decisions that are traditionally driven by intuition. Football clubs spend hundreds of millions on transfer every day, and increasingly, the ones making the smartest moves are the ones with the best data pipelines. This project at a smaller scale mirrors exactly that process. Thank you very much.